Hi there, and welcome to Bayesian model updating in OpenCossan. In this video, we'll look at how Bayesian model updating is implemented in OpenCossan. For this video, there are two prerequisites on the theory of Bayesian model updating, which, if you haven't seen, check them out now. So just as a quick reminder, what we're trying to do in Bayesian model updating. So it's a method for model calibration. So say you have some function, f, which could be some sort of mathematical representation of any sort of computational model you have. And say that f takes in two variables, k1, k2, and outputs two variables, y1 and y2. So the dimensionality of f here is arbitrarily picked, so it doesn't have to be 2 to 2. In general, this works for functions of any dimensionality. So you could have had three variables on the left and two on the right, or any number really. And the problem that we have is that we don't know the variables k1 and k2, and we'd like to somehow find them. But what we're presented with is a bunch of data of f's output, and we'd like to somehow use this data to construct a probability distribution of k1 and k2. Often the data is picked with some sort of uncertainty, and you'd like that this calibration technique captures the uncertainty in the output data. So this kind of thing, where you construct a probability distribution of your input parameters such that the output is somehow represented in this in these input parameters. So this is done probabilistically by solving Bayes' law up in the top left right corner, and this is done by multiplying two things together. This thing called a prior, which is kind of your initial guess of your input parameters theta. You multiply this by another distribution called the likelihood, and this basically tells you how likely each point in your input space is. And you multiply these two things together and you get another probability distribution called the posterior, which is then sampled with Markov chain Monte Carlo methods. And this is just a small illustration of how the algorithm works. And typically we don't do this in one go. So we do something called a transitional Markov chain Monte Carlo, where this Markov chain Monte Carlo steps is done a couple of times. And this allows us to sample from really high dimensional probability distributions and multinodal ones like the one that's shown. So this is how the workflow is set up in OpenCossan. So you start off with a prior. So the priors are going to be random variables, probability distributions. You insert this into the model, and you hand this model to the likelihood function. The model here is the f. So this is the computational model you'd want to calibrate. You then give the likelihood some simulation data. So this is the calibration data, the output data of your model. You again give the likelihood to the Bayesian model updating class, which then has this method apply TMCMC, which will basically calibrate your model and will output samples of your calibrated model. So in the OpenCossan implementation, if you look inside the OpenCossan directories, you see in inference is where these methods belong. So there's a new Bayesian model updating class, Bayesian model updating, which has a couple of methods: apply, TMCMC. There's also a likelihood class also. This is just a brief sample of what some code would look like to perform Bayesian model updating in OpenCossan. In the next video, I will go through this example line by line. But basically, you start off by defining a prior, which would take in two random variables. In this case, they're both uniform. You put them into a random variable set. So if you would like to give some sort of correlation to the random variables, you do it in the random variable set. And then you insert that into an input object, which is then given to the model. The model is then given to the likelihood, which is then given to the Bayesian model updating class. And then the final step there is just to apply the calibration algorithm, apply TMCMC. So the example we're going to look at in the next look at the next video, is this one here. So K1 and K2 are basically going to be elements to a matrix, which we're then going to do, we're going to find the eigenvalues of y1 and y2. So our model will just be this eigenvalue model where the inputs are k1, k2, take the eigenvalues, and the outputs are y1, y2. We're going to for this to happen, we need to basically generate some sort of synthetic data of y1, y2. So we're going to generate data of y1, y2, and then calibrate for k1 and k2. So we're going to do this by setting k1 and k2 to 1. This corresponds to these two eigenvalues. And then we're going to perturb these values with some Gaussian noise. And we're going to use this as our calibration data. So from this data, we're going to try and infer back the values of K1 and K2 that we began with. And just to show you what the answer is to this calibration process. So on the left is basically showing samples of our input space, so K1 and K2. What you can see is that we have two values of K1 and K2. You can see at 1, 1, the original answer that we began with, but also we have another cluster of samples around 2 and 0.5. And this is because both of these locations give back the answer that we begin with. So this problem is called non-identifiable, which means that we don't have a singular solution to the calibration, but we have two. But the real strength of Bayesian model updating is that it can work for multiple solutions. That's plotted, and what's plotted on the right is basically our calibration data versus our a calibrated model. So the orange dots are basically the calibration data that we began with, and the blue dots, they correspond to basically samples of the posterior. So each point in the input space, sample in the input space, propagated out to the output. Okay, thanks for listening. And in the next video, I'll basically show you how to perform this example in OpenCossan. Thanks.